Good morning. So today we're going to go over Unit 2, Day 14 notes. We're going to solve trigonometric equations. First, let's look at sine. I have sine equals negative cosine of theta. If I add cosine to move it to the left-hand side, sine and cosine will not be one trig function. And my strategy is to rewrite in terms of a one trig function. Well, I'm going to have to then divide by cosine. Leave that negative there. Divide by cosine. Sine over cosine is tangent. So we're saying, where is tangent of theta equal to -1? Because there's still a -1 here. And really, I can write down all multiples, but I really only want between 0 and 2 pi. So I have a range that I can look at. I know that tangent is negative in the second quadrant and the fourth quadrant. So there's going to be two spots where tangent is -1. I know that tangent is -1 in the 45, 45, 90 degree triangle because if this is 45, 45, 90, 1 square root of 2, tangent is opposite over adjacent, and this is the only time when they're equal, so that gives us 1. So this is, we're going to write it in radians because my range is actually in radians. So this is pi over 4, 2 pi over 4, 3 pi over 4. So tangent is -1 when theta is 3 pi over 4. And then 4 pi over 4, 5, 6, 7, and also at 7 pi over 4. In the future, if they don't give us a range, we might write it as multiples of pi. So or multiples of 2 pi. So we'll say theta is at 3 pi over 4 plus, and then 2k pi. 2 pi, and then times a number. So just think about that in the future if they don't give us a range or an interval. Let's look at cosecant. Cosecant is the reciprocal of sine. So this is the same as sine of 1/3 theta equals the reciprocal of -2, which is -1/2. I know that this is my 30, 60, 90 triangle, so I'm going to draw it over here. We can use it. It looks like this one might be the 60 and 30. So opposite the 30 is always the 1, 2, square root of 3. You know that sine is opposite over hypotenuse. So opposite, we want -1/2. So opposite 1 over hypotenuse 2. That means 30 degrees is my reference angle. So we're going to say, since these are actually in degrees and not radians, I can just say in degrees. Now, we need to know when sine is -1/2. That's not at 30 degrees because that's in quadrant 1, and sine and cosine are positive. So I need to know where sine is negative. Sine is negative in quadrant 3 and in quadrant 4. So I'm going to say in this quadrant, this is 180 plus 30 degrees. Which is when my 1/3 theta equals 210 degrees. So I need to divide by 1/3 or just multiply by 3. So times 3 maybe, times 3. So I know when theta is equal to 630 degrees. And that's in between 0 and 720. So this would work. Now let's see if the other one works. This one right here would be 330. So this is 360, and then minus this is 30 degrees. So this is 330. So I'm going to do it up here or down here. So I have 1/3 theta equals 330 degrees. When I multiply by 3 on each side, I get when theta is equal to, 990. 990 won't work because that's not in between 0 and 720. So really the only thing that works is when theta is 630 degrees. That's when sine is -1/2, or when cosecant of 1/3 theta is -2. That's the only thing that works. All right, it says tangent of 2 pi, or 2 theta, equals -1/3, but remember, our theta has to be between 0 and 3 pi. So it looks like they want us to write it in radians. Well, I know that tangent is -3, or square root of 3. I know that the only time we're going to have a square root of 3 is in my 30, 60, 90 triangle. So tangent is opposite over hypotenuse. Opposite, we want to be the square root of 3 over 1. So actually my reference angle in this case is going to be 60 degrees. So 60 degrees is pi over 3. Now tangent is negative square root of 3. So tangent is negative in quadrants 2 and quadrants 4. Okay, so I know that 2 theta has to equal, well, this is pi over 3, so this is 2 pi over 3, plus any multiple, so I can say 2k pi. Or tangent is negative square root of 3. If this is 2 pi over 3, 3 pi over 3, 4 pi over 3, this is going to be 5 pi over 3. So I can say 5 pi over 3. And this is still plus 2k pi. However, I need to divide everything by 2 to find out what theta is going to be. This is 2 theta. If I divide by 2 in this fraction, I'm going to have theta equals pi over 3 plus 2k pi. Or if I divide this one by 2, I'm going to get, I guess, pi over 6, or 5 pi over 6. I can't divide side by 2. So 5 pi over 6 plus, this is going to be just k pi. And this one also was just going to be k pi. We're dividing everything by 2. So let's find out what would work in between this, in between 0 and 3 pi. So I know theta can equal pi over 3. Pi over 3 plus pi. And then we have 5 pi over 6. So pi over 3 plus pi is going to be, or let me just do a comma, sorry. 4 pi over 3. And then plus pi, plus 3 over 3. This would be 7 pi over 3. Plus 3 over 3, 3 pi over 3. This would be, we can keep going, but also 5 pi over 6. So 7 pi over 3 plus 3 pi over 3 is 11 pi over 3. 7, 8, 9, sorry, 10 pi over 3. And then we have also, we're only going to go between 0 and 3 pi though. So we have 5 pi over 6, 11 pi over 6, and 17 pi over 6. I do. There's a lot of these. There's too many. I want you guys to try number 4. So this one, it looks like we're going to have to factor. It says 2 sine squared theta minus 3 sine theta plus 1. If it helps, you can change these to x's. So 2x squared minus 3x plus 1, and see if you can factor that way. This 2, I know the factors of 2 are only 2 and 1. So I know this has to be a 2 sine theta times sine theta will give us 2 sine squared theta. And then I know the factors of 1 are 1 and 1, so it doesn't matter. Now the positive and negative do matter. In this one, it looks like they're both negative because when we add, we want them to be negative, but when we multiply, we want them to be positive. So a negative and a negative will give us negative 2 sine minus sine is negative 3 sine. Great. And then negative 1 times negative 1 is positive 1. Okay. So when I factor this, I can set each one equal to 0. So I have 2 sine of theta minus 1 equals 0. And then I have sine of theta minus 1 equals 0, right? And then we're just solving this like normal. We're adding the 1 over. So I have 2 sine of theta equals 1. I'm adding the 1 over. So sine of theta equals 1. When is sine equal 1? And then I also have to divide by 2, so sine of theta equals 1/2. When is sine equal to 1/2? I know this is probably going to be my 30, 60, 90 degree triangle. I did this on top. Sine is 1/2 at 30 degrees. So I did that one already on top. They want us to write it in terms of radians, though. What I did was I factored. Okay, so I'm going to write it in terms of radians. 30 degrees is pi over 6, so I know that sine is 1/2, positive 1/2, at when theta is pi over 6, and plus any multiple of that. Also, sine is positive in the second quadrant. So I also know that at 5 pi over 6, sine is also 1/2. And sine is positive 1. So sine are my y values. My y values are positive 1 at pi over 2 only. So pi over 2 plus 2k pi. So within this interval, all I have is pi over 6, 5 pi over 6, and pi over 2. Those are not in the right order. So let's try this one also. It looks like we're going to factor again since this cosine is squared. However, I need to move everything to one side. So I have 2 cosine squared x, add it, so plus cosine x, and then subtract it, minus 1 equals 0. We always have to get everything on one side, set it equal to 0, and we usually want our leading coefficient to be positive. I know to factor this, we're going to have 2 cosine x and cosine x. And then we're going to have, 1 and 1. This one's the same. And then one's going to be positive, one's going to be negative. I want the bigger one to be positive. So this one's positive. This is the bigger one. And then this inner ones are going to be negative. I want you guys to finish this and try it out. Tell me what the x is going to equal. Finish this. So sometimes we're going to have to apply our trigonometric identities, especially our big one that says sine squared theta plus cosine squared theta equals 1, our Pythagorean identity. If I solve for cosine, I get cosine squared theta equals 1 minus sine squared theta. And this is a really important identity to remember. So I know that I need to get everything in terms of 1, either sine or cosine. I can't have both. So this is cosine squared. I can replace this with 1 minus sine squared. I cannot replace anything with sine because it's not squared. So I'm going to replace this with 1 minus sine squared theta, and then I still have plus sine theta. I'm going to subtract the 2 and move it over, equals 0. I can now simplify this. I have negative sine. I don't really want this to be negative. I'm going to fix it in a minute. Negative sine squared theta plus sine theta. And I'm going to add these. Negative 2 plus 1 is negative 1 equals 0. And then what I can do is I can just divide everything by negative 1 because I don't want my leading term to be negative. So I have sine squared theta, change the sign, minus sine theta, change the sign, plus 1 equals 0. I can factor this. It looks like it would be kind of hard to factor though. I don't know how you can have a factor of 1 and 1 and still get the difference is 1 or a negative 1. So what we'd have to use is the Pythagorean theorem, or is the quadratic formula for this. I'm just going to see real quick if there's a solution so we don't have to go through the whole quadratic formula. If the discriminant is greater than or equal to 0, I know there's going to be a solution. So I'm just going to look at the discriminant, which is b squared minus 4ac. Remember, we can't have a negative underneath that square root. So I'm just going to check it out. My b is a number in front of my sign without the squared. So this is negative 1 squared minus 4a, and then c is 1. And I'm just going to see if it's bigger than 0 or equal to 0. Negative 1 squared is just 1 minus 4. Oh no, 1 minus 4 is negative 3. Oh no. It's actually less than 0, so therefore there are no real solutions. Alrighty, and this one, it looks like I have a identity right here. So I wrote down the identity, sine of 2 theta equals 2 sine theta cosine theta. But this is sine of 2 times 2x. So I'm going to have 2 sine of 2x cosine of 2x equals sine of 2x. Now I can subtract the sine from both sides, from this side, and get 2 sine of 2x cosine of 2x minus sine of 2x equals 0. And then sine of 2x, I can pull out a sine of 2x from both terms. So this is sine of 2x parentheses. I still have a 2 in here, cosine of 2x minus 1. I still need that 1 for a placeholder. And now I can set each one equal to 0. So I know that sine of 2x equals 0. And then 2 cosine of 2x minus 1 equals 0. And if I add the 1 and divide by 2, I get cosine of 2x equals 1 over 2, positive 1 over 2. And then sine of 2x is 0. I know that sine is 0 on the x-axis. Oh, cool. Look at this. So I know that 2x, oh, that does not, you cannot see that. 2x equals, on the x-axis, that would be 0 plus 2k pi, and then also when my 2x equals 180 degrees, or pi plus 2k pi. I really do need to divide by 2 on each. When I divide by 2, though, from 0, this is just going to be when x equals 0, plus k pi. And then when I divide 2 on each, we're going to say when x equals pi over 2 plus k pi. And then on the cosine side, haven't done this side yet. Cosine is 1/2. 1/2, that's my 30, 60, 90 degree triangle. And this is 60 degrees. So I think that is 2x equals pi over 3 plus 2k pi. When I divide by 2, I get x equals pi over 6 plus k pi. Also, cosine is positive in the 4th quadrant. So I know that this is going to be 1 before 6 pi over 3, which is 5 pi over 3. So it also, when 2x equals 5 pi over 3 plus 2k pi. When I divide by 2, I get when x equals 5 pi over 6 plus k pi. You guys can find out those and just say when x is equal to, and then write them all out. So those are all I'm going to do today. You guys can try the rest and let me know if you guys have any questions.